Superbrain uIDE tech demo, take 3. So in this third part we're going to have a look at the IDE mapping software. It's called xmap.com, and at the end of the last video you can see it wasn't working properly because I had made changes to the driver but not to the mapping software. Well, I've done that now and checked it out and it appears to work properly now. So here we are on our boot screen. We'll go and boot the machine, and here we are at the CPM prompt. As before, we can see the utilities. Let's launch the X driver so we can see all our drives. Now we also have, so we've got this program called xmap which changes this drive map. But first of all, let's have a look and see what the current drive map looks like. So I do xmap and I say -I, and this is the input. This is where it's going to read its input from. I want it to input from memory. It could input from the X driver file as well, so I could just look at what's in the xdriver.com file, the map that's in there, which is what it uses to initialize the driver when it loads it. And I'm going to ask it just to print the map, and we should be able to see then that we have drive A mapping to the first floppy, it's enabled. B to the floppy 01, that's this one on the right here, that's also enabled. And then we have C, D, E, F all the way up to P, and they're mapping to these IDE drive numbers. And it says master because the IDE device, or rather the IDE standard, allows us to add a second one of these DOM cartridges. It has a little switch on the back that turns it to a slave drive, and that means that in theory, well actually not theory, in practice, with the right hardware setup, the right cables and things, you can actually have access to 256 megabytes. And if you had that, you'd need to use the mapping program in order to map in different segments from the masters and slaves. But at the moment, the default setting for the demonstration is just to get the first 14 partitions from this IDE drive and map them from C to P. However, I do have other partitions on this drive which are numbered 14 and 15, and I can map those. So let's just say I'm not really going to use drive B. I need drive A because that's where my boot comes from. Although actually I may actually be able to map it because the BIOS, sometimes the BIOS just goes and reads the tracks from drive A irrespective of what the rest of the code in the BIOS is saying. So I might be able to reassign drive A as well. But for now, let's take drive B and let's assign it to the 13th partition, which is IDE master 14, actually, because they start at 0 on the IDE card. So I'm going to use xmap screen editor. So xmap -im, so I want to get it from the memory and I want to just edit it like that. I can also print it out as well. If I print it out, it will print out this thing after I finish editing. So it loads up. It'll take a copy of the current mappings, and there they are. And then it gives me this copy of that table with a cursor on it, and I can go and change things. And I use the up and down keys, left and right, to move these things. And if I want to change the value, I use the space bar. So it's just a simple little user interface that just makes it a little bit easy to play around. So the first thing I need to do if I want to reassign drive B, this one here, from a floppy to an IDE, is to change the type. It needs to be a master, IDE master. You can also change it to a slave, but we don't have an IDE slave on this connected, so it won't work. So we'll set it to an IDE master. The ID I need is 14, so I've got to change that to 14, and of course it's already enabled. So I'm done. So I hit escape. It says it's updated. I've got to confirm that I want to change it. So I press Y, and it prints it out. So now we've got this printout, which says drive B is mapped to IDE master 14. I'm a little bit concerned because it shouldn't say DPH00 there, so we'll just have to see how that goes. It might work, it might not work. So let's have a look. If it doesn't work, I'll be making another video showing it working. Alright, so I have drive B now. If I do a dir of B, hopefully we'll see activity on here and there'll be something to show. Yeah, I don't think that was I don't think that was what we were looking for. Let's check. Minus P. Oh no, okay, so it hasn't changed. It hasn't changed anything. Let's try again. Xmap. I'm going to use a command line option now. No, I'm not. Minus IM. Oh, I know why it hasn't changed it. Okay, so when I edit the map, I have to specify where the mapping program will read it from. Now there are two options. It can either read it from the in-memory driver, which is what I loaded, or it can read it from the loader program. So those are the two options. There's another option which loads a default map as well. So if you get it completely wrong, you can load default map. And then when you output the results of your editing, you can either output it to the in-memory map or to the file. Now if you output it to the driver file, that means next time you load the driver, it will have your changes incorporated in it, because the mapping program actually patches the file directly to change the map that's in there that it loads when you load the driver. So I'm going to do that again, but I'll have slightly different arguments to the Xmap program. So I do Xmap, I want the input from the memory, I want the output to the memory, so now I'm editing the existing memory map that's already loaded, and I'll use the screen editor again. Okay, so I need to go to drive B, change that to a master, and the ID is 14, and it's enabled, so leave like that. So we're doing escape, do yes, and now if I do a dir of B, there you go, it's hit the IDE drive. Now because this disk 14's got nothing on it, you can't stop. Yep, I just need to tidy that up, which is an artifact of the formatting program that has a bug in it. Now if I do dir again, no, there's nothing on there. Now we can use Xmap just to look at the drive map and see what you know, whether our changes have taken effect. So we know they have, because we know now that drive B is hitting the IDE drive and not the floppy disk. So minus IM minus P. So I read the map from memory and print it to the screen. There you go. B is mapped to IDE 14. Like I said before, there you go, DPH00. So it's moved the DPHs down. So yeah, that looks correct. That looks pretty good. But of course, the next time I reload my driver, it's going to have B as a floppy, because the driver file, the loader file, the map in the loader file, I should say, is not having B mapped to IDE 14. So if I want to edit that, again, Xmap minus I, and this time F, so I take it from the file, which is hard-coded to xdriver.com inside the Xmap, so I don't have to specify the name of it. And then I want to, again, output to the file, and again I'll use the screen editor. Okay, so you can see when you look at this, this has come from the file. So it copies that into that, and now I've got to edit this accordingly. So I'm going to change that to a master, and it will be 14. It's enabled, so I escape. Now this time when I update it, it will write the changes to the driver file. So now none of these Xdriver utilities are doing a warm boot, and that's why I'm able to do this without breaking the driver. So it's not like pip or other programs that always execute a warm boot when they come out of, when they want to go back to the CCP. What I do is, you don't have to do a warm boot. If your program is well behaved and it maintains the stack properly, you can just do a return at the end of your program and it'll just go back to the CCP. As long as it doesn't need all that memory that the CCP is occupying at the top of the TPA. That's the caveat. So the utility programs, I know how big they are, so I just return to the CCP without doing a warm boot, and that's why the driver is still working after calling them. Alright, so I've changed my map. I've written it to the driver file. I'm going to do a hard boot now, and that will take out my driver completely, and I'll have to reload it. So, okay, so now I've got to load my driver again. Now this time, if you look, it's reporting that the map is different. I've got one floppy at drive A, and I've got IDE drive B to P inclusive. So if I look at B like before, I should see, well, you saw the activity on there. Now there isn't anything on B, so I've got a pip on here. There's no pip on here. Okay, so let's go to C. Oh, actually no, don't you remember that we copied all of B to K, so if I go to K, actually I won't, I'll just do K colon pip, whoops, this time K colon pip. I know there's a pip on K because we copied all of that from B in the previous video, and then we'll say B colon equals K colon star dot star, and this will copy everything back onto B. But remember that whenever we use pip, it does a warm boot, so it's going to reset the drivers. Dum 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 dum. I think I should go and make a cup of tea while this is working. Nearly there. There you go. So now if I look at what's on B, which remember is an IDE drive, not the second floppy disk. Alright, so this has happened because pip has done a warm boot, so I need to load the driver again. So again, it's going to honour the settings that I set up in the XMAP program. And now if I look on B, I don't see anything. That's a bit weird. There it is. Okay, so it looks like there's still a bug there somewhere. It should have shown me the contents of the IDE partition 14 when I asked it to look at B, but it didn't. But it did work on reset. So anyway, that concludes the demonstration. What happens next is I have to write a whole new BIOS with all this software in it, so that it works as you would expect. You don't have to keep on reloading the driver. Don't know how long that's going to take, probably a long time, but when it's complete, yeah, I'll show it to you. Okay, thank you very much for watching. Bye.